Chapter 25, Amides and Amines, the organic nitrogen compounds. Amides are neutral nitrogen-containing compounds. They are not acidic and they are not basic. They are neutral. They are molecules in aqueous solution and as pure substances. And they contain a carbonyl group, which is directly connected to a nitrogen atom. Some of these make up very common solvents, like dimethylformamide is water soluble, and it's used a lot in organic chemistry because you can have one of the hydrogens replaced with an organic group or both hydrogens replaced with an organic group. Like dimethylformamide, there's two methyl groups coming off the nitrogen, making it aprotic with no hydrogens that can pop off. Amide preparation, we can react a carboxylic acid with ammonia, which forms an ammonium salt because it's an acid-base reaction, and then under heat we get the amide and water is removed. Amide preparation, ammonium salts of carboxylic acids can also be converted to amides by heating. So ammonium salts of carboxylic acids are converted into amides just by heating. So once you have the salt, you just have to heat and get your amide in water. Rules for naming amides. You name the longest continuous carbon chain. Again, the carbonyl carbon is always number one. We drop oic from the carboxylic acid name and end amide. So methanoic acid becomes methanamide. Ethanoic acid becomes ethanamide. Propanoic acid becomes propanamide. And methanamide is also called formamide, just like dimethylformamide. So again, formic acid becomes formamide, butyric acid, butyramide, benzoic acid, benzamide. So we can convert the common names into amide names by the same practice. So write formulas for N-methyl pentanamide. That just means there's a methyl group coming off the nitrogen. Then there's NN-diethyl 2-methylhexanamide. So pentanamide here, we have 5 carbons. We have our amide. And then N-methyl signifies that there's a methyl group coming off of a nitrogen. Here we have NN-diethyl 2-methylhexanamide. So 6 carbons in the longest chain and a methyl group coming off of carbon 2, or the alpha carbon. Physical properties of amides. We have hydrogen bonding. They're very polar, they're very water soluble, and they're very useful solvents in organic chemistry because of that. And they have a lot of hydrogen bonding. They are colorless and odorless solids except for liquid formamide. Hydrolysis. Amides undergo acidic and basic hydrolysis, producing a carboxylic acid or a salt, respectively. So under acidic hydrolysis, you get a carboxylic acid. Under basic hydrolysis, you get the basic salt. So the acid and basic hydrolysis of the amide, again with the acid, you just get the carboxylic acid in the acidic form because you're in an acid. And with the base, you end up with the salt because you're in a base, and so a base removes the proton from the carboxylic acid to get the salt of it. Polyamides, condensation polymers that contain repeating amide units, just like another polymer. So polyamides, like synthetic nylon. Nylon produces amide bonds, like we see here. And nylon was one of the first synthetic fabrics. NY stands for New York, LON stands for London. And we have biological polymers, like the protein chymotrypsin, in which we form amides. Peptide bonds in any protein are always amides. Urea is a diamide. There's an amide on both sides that is excreted in urine. It is a metabolite the body uses to get rid of extra nitrogen. And so this is how humans excrete nitrogenous waste. In the urea cycle, it's packed into urea and you pee that out. It's a white solid, very soluble in water. Urea is a common commercial product. It's used in fertilizers to add nitrogen to the soil. So is ammonia. Some places prefer urea over ammonia because there are some areas of the country that are more prone to theft of anhydrous ammonia for methamphetamine manufacture. And so by utilizing a urea, you can get around that problem and still put nitrogen into the soil without that worry. It's also the starting material in the production of plastics and barbiturates like barbituric acid. Classification of amines. So that was amides, now we're in amines. So there's no carbonyl group, just the nitrogen. We have ammonia, then we have primary amines, they have one carbon on them. Secondary amines, 2 carbon groups, and tertiary amines, 3 organic groups attached. And they can be aromatic or aliphatic. So, and again, if it's aromatic, it's an aniline. Classify the following amines as primary, secondary, or tertiary. Here we have primary. There's only one organic group coming off the nitrogen. Here it's tertiary. We have 1, 2, because there's 2 methyl groups. Then 3 groups coming off the nitrogen. And here we have secondary. You got 1, and then the methyl, 2 groups coming off of the nitrogen. IUPAC rules for naming amines. Name the longest continuous carbon chain containing the amine group and number the carbon to the amine with the lowest number. And so you put the lowest possible number at the amine group and you drop the E from the alkane ending and give it amine. So propane becomes propanamine. Ethane becomes ethanamine. Cyclohexane becomes cyclohexanamine. Use a prefix with a capital N italicized if the amine nitrogen atom has an alkyl group attached to it. So if it's a secondary or tertiary nitrogen, the biggest carbon chain goes into the root name. But anything else attached to that nitrogen starts with an N prefix. Like here, N-methyl-1-propamine. Again, your biggest chain gives you the name propamine, and that's N-methyl. Or here, butanamine, 4 carbons gives you your base chain, but you have 2 more substituents coming off the nitrogen, a methyl and an ethyl, N-ethyl and methyl. And ethyl becomes before methyl because in the alphabet, E is before M. N-dimethyl, 3-ethyl, 1-pentanamine. Again, our base chain is 3-ethyl, 1-pentanamine. And we have 2 methyl groups coming off the nitrogen, N-dimethyl. N-dimethyl cyclopentanamine. Again, you have your cyclopentanamine, and then 2 methyl groups coming off the nitrogens. So that's why you have the italicized capital N's. And notice when there's you get, even if there's 2 groups coming off, you have both N's, N, N. The 2-nitrogen, the diamine compounds. Here we have, they end in diamine, 1,3-propane diamine, 1,6-hexane diamine. Notice the final E of the alkane is not omitted. It's 1,6-hexane diamine. That last E is there now. It's not omitted like it was before. Common names for amines. We name the alkyl groups or groups attached to the nitrogen atom following by the ending amine. Ethylamine, propylamine, and notice instead of propanamine, now it's just propylamine. And so the common names are similar, just slightly different. And all the groups attached to nitrogen end in -il here. Isopropylamine, instead of 2-propanamine, this is isopropylamine, the common name. Secbutylamine, tertbutylamine, ethyl dimethylamine instead of N-dimethylethanamine, which is the formal name. So this is how we name the common names for amines. Aromatic amines. The most important one is aniline. Nitrogen's coming directly off the benzene group. Derivatives are named as substituted anilines. So N-methyl aniline, there's a methyl group coming off the nitrogen. And N-dimethyl-aniline, 2 methyl groups coming off the nitrogen. And ethyl and methyl-aniline. There's a methyl and an ethyl group coming off of the nitrogen. And again, when you have multiple, they're named alphabetically, which is why ethyl comes before methyl. Whoops. E comes before M in the alphabet. And when you have 2 of the same group coming off the same nitrogen, you see it twice, N, N. And that N is both capitalized and italicized. Aromatic amines, when a group is substituted for a hydrogen atom in the ring, the resulting ring is a substituted aniline. So here we have orthomethylaniline, or we can call it toluidine. Meta-methylaniline, para-methylaniline, and ethylaniline. Meta-ethylaniline, 2,3-dimethyl-aniline, para-chloroaniline. The aniline is the group name. And chemically that makes sense. In later organic classes you'll see that the electrons from the nitrogen actually do delocalize with the ring, giving it different properties than what you'd expect for an amine. Give names for the following amines. Here we have, they want the IUPAC and the common name. So, IUPAC, N-ethyl, N-methyl, 1-propamine. Base chain comes from the longest chain. 1-propamine, N-ethyl, N-methyl. Ethyl comes before methyl because of its order on the alphabet. Common name, ethyl-methylpropylamine. And again, alphabetical. Ethyl E, methyl M, propyl P. IUPAC name, here we have 3-pentanamine. So it's a pentane with the amino group at carbon 3. Heterocyclic compounds. These are aromatic rings which have 2 or more atoms that are different. So we can have oxygen, nitrogen, and sulfur are the common heteroatoms. So here we have pyrrole. And this is actually aromatic. Because of those 2 electrons, you have a delocalized 6 in there. Pyridine. Piperidine, not aromatic. This is alkyl. Pyrimidine, that's aromatic. And purine. And if you notice when you study biochemistry, the DNA is pyrimidines and purines because the adenine and guanine are like purine. Cytosine and thymidine are like pyrimidine. Physical properties of amines. They hydrogen bond with water. Aliphatic amines with up to 6 carbons are pretty soluble in water. After that they get less and less soluble as they have a bigger and bigger fat-soluble group. They have a fishy odor. Trimethylamine has a very fishy odor, but pretty much whenever you have a nitrogen you get a fishy odor. 2 nitrogens gives you a really terrible odor. Notice that 1,5-pentane diamine is literally called cadaverine. 1,4-butane diamine is putrescine for putrid. So again, when you have more than 1 amino group, you get a really, really bad smelling molecule. In general, the 2 chemical moieties that the human nose is amazingly sensitive to is nitrogen and sulfur. You can smell nitrogen and sulfur in extremely small amounts, and they smell extremely bad to the human nose. Preparation of amines. Here we have the alkylation of ammonia, the reduction of amides, reduction of nitriles, and the reduction of aromatic nitro compounds. So we can methylate. Here we start with ammonia. If you put 1 methyl group, we have methylamine. Another methyl group, dimethylamine. 3 methyl groups, trimethylamine. This is a very hard reaction to control though, and so in the end when a chemist does this, you typically get some of everything. You get a mixture of all 4 compounds when all is said and done.